Composition cycles in Earth's atmosphere. When we look at the elements found in Earth's atmosphere, what we find is that these remain more or less in balance, and that has to do with how these elements cycle both into the atmosphere and out of the atmosphere. The primary elements we find in our atmosphere, 78% is nitrogen, and so this purplish blue wedge in our pie chart represents the nitrogen. 21% oxygen, so that's our green wedge. We think of our air as being mostly oxygen because that's what we breathe, that's what our bodies need, but nitrogen actually dominates. Water, 1% of our atmosphere is water, which is this yellow wedge here. Carbon dioxide's pretty small, 0.03%, but we do want to talk about that. Argon we're kind of leaving out of our discussion because that is an inert gas. It doesn't really react with anything, but it just happens to be there. So let's look at how these things cycle in and out of the atmosphere. So the first one we're looking at is nitrogen. And nitrogen is removed from the atmosphere by bacteria. And as you see in the little graphic here, bacteria fix the nitrogen for use by plants. So the bacteria react with the nitrogen and become part of the soil. And so then plants absorb that nitrogen into them. So when plants die, or when the animals who eat the plants die, the nitrogen is released. So decay, this would be both plants and animals. So if you want to think in very stark terms, death gives us nitrogen. So the fact that we have so much nitrogen in our atmosphere, I guess, is a testament to how many plants and animals have died over the years. Oxygen, of course, we inhale oxygen, so all animals will remove oxygen from our atmosphere, including you and me. To get oxygen back into the atmosphere, plants, and this is where photosynthesis I knew better than to try to talk and spell photosynthesis at the same time. So plants, through the process of photosynthesis, release oxygen into our atmosphere, and that's the original source for oxygen in our atmosphere. Because plants take in carbon dioxide, which has oxygen in it, they use the carbon, but give off the oxygen. Water. Water is removed from our atmosphere by rain, or really more appropriately, condensation. So anytime you have a nice cold drink and there's water condensing on the outside of your glass, you are removing water from our atmosphere. It's returned through evaporation. So as the water evaporates, the sunlight hits the water and it evaporates, we get water back into the atmosphere. And our most complicated one, carbon dioxide. Lots of different ways to remove carbon dioxide from the atmosphere. So we've got photosynthesis, so that's plants, because plants absorb carbon dioxide. Water does a good job of absorbing carbon dioxide, and some chemical reactions with rocks, for example, will react with carbon dioxide as well. So lots of possible ways of removing carbon dioxide from the atmosphere. Lots of ways of putting carbon dioxide back into the atmosphere. Exhaling. When we exhale, that's the animal respiration here, we are exhaling carbon dioxide. Volcanoes. When volcanoes erupt, one of the primary gases that comes out of a volcano is carbon dioxide. Now, both of these are natural sources. Then we've added a man-made source, and that is burning fossil fuels. That's what we see here. Whether it's gas, oil, wood, coal, all of these things release carbon dioxide when burnt. And so that's what has led to an imbalance in the CO2 cycle, because we are adding, in addition to our natural sources, non-natural sources, and our way of taking carbon dioxide out of the atmosphere hasn't changed. So we are putting carbon dioxide out faster than our natural processes can remove it from the atmosphere. And that's kind of the underlying concern with global warming and climate change, which you will be seeing in another tutorial.